Okay. So, we have an exam tomorrow. Exam number 2. What is on the exam? It's matrix operations. This is basic, just addition, subtraction, and multiplication. Second thing is matrix inverse, or the inverse of a matrix. The third thing is the determinant of a matrix. Sounds about right, right? So, I think you guys are pretty solid on operations.
One of each. And then I have a question for 2.
Okay, so. Matrix operations. So matrix A equals 3, 7, 9, 2. And some matrix B, which equals 1, 4, negative 3, 7. And I say, find these 3 things. I say find A plus 3B, A times B, and 2B times A minus A. You can do all those, you're fine. What was that?
The multiplying part.
First row times first column. So 3 times 1 plus 7 times negative 3, right? And then the first row times the second column, so 3 times 4 plus 7 times 7. And then, you got it?
Yeah.
Sorry, can we copy it down wrong and we get the answer the wrong one? Use it with partial.
Just don't copy it down.
I didn't realize I did until I looked up.
It's okay.
How many questions for each are we gonna have on it?
It would probably be something like this for matrix operations. We could have 3 like this. Brandon, do you know how to multiply the 2 matrices? Yeah? Perfect.
Can I look at my iPad from there? I like my iPad on
You need to get right now. Why do you need it right now?
So I can take a picture because I'm gonna take forever today to finish this.
Okay.
And I want to move on so I can get the other photos.
quick.
Yeah. I'm just writing everything down because the class message.
Okay. I'm videotaping too. Okay. You guys done?
Yeah, I'm good.
Good? Alright. You're also, for the record, all of these, 1, 2, and 3, matrix operations, matrix inverse, and determinative of matrix, you will be given questions that you'll have to use a calculator. For instance, like, I'll give you multiplying 2 matrices that to do it by hand would take forever, right? So you'll have to use a calculator. So you'll have to know how to use a calculator to do all these things.
But not all of them, right? Just like some.
Yeah, like I'll give you simple ones like this, and then I'll give you ones that you'll have to use a calculator. I mean, you won't have to use a calculator, but they would take the rest of the exam to solve it by hand. Okay. And before I do anything else, if I have matrix A that's a 3 by 7, and matrix B that's 7 by 9, and I multiply them those two together, what do I get? A matrix that's what? 3 by 9. Do you guys get that? If I multiply 3 by 7 by 7 by 9, I get a what, Brandon?
3 by 7.
By 7 by 9, I'll get 3 by 9, right? Could I multiply a 7 by 9 matrix by the 3 by 7 matrix? Could I do that? No? Oh, I don't end up with like a 7 by 7 matrix? No. Can I? I can't, right? Because what has to be the same? The inside terms have to be the same. Right? Alright, good. Alright. Shall we move forward?
Yes.
Can I erase everything? All right. Finding the inverse of a matrix. Okay. If I have a 2 by 2 matrix, A, B, C, D, this is matrix A. What's the inverse of matrix A? What's A inverse?
1 over AD minus BC.
1 over AD minus BC times
No, it's negative
D,
negative B,
negative B,
C, negative C.
Good. So if I have matrix A is equal to 1, 2, 3, 4, find the inverse of matrix A.
Sure, how do you find the matrix of like I know how that's 2 by 2. The one is 3 by 3.
The inverse of 3 by 3? That's where we're going.
I was in and out that day.
Yeah.
Thank you.
And unless I specifically tell you not to, you should take the outside term and multiply it through. And that should be your answer. That's a mistake.
No, I made a mistake. I switched
I did
keys.
make a mistake. Everyone got that?
Yep.
Alright, good. Erase it. Yes. Alright. The most tedious thing that you're going to be doing on this exam is this next part, which is finding the inverse. You can find the inverse of any square matrix. For the record, does a matrix have to be square to get an inverse?
No.
Yes.
That's
And
square the inverse?
it has to be squared to be the inverse. And what's A inverse times A? It's an identity matrix,
It has to.
right?
Mm-hmm.
Which is also equal to A times A inverse. The matrix times its inverse is the identity matrix. Cool? Alright. So, let's say, and you can count on the fact that I'm going to make one relatively easy.
What did you have on the right side of that?
Oh, just A times A inverse, just the flip of the original. Okay? You can count on the fact that I'm going to make it relatively easy. Does it mean it's going to have no fractions? Maybe, maybe not. But you can pretty much be assured that if you've got crazy fractions and a whole bunch of weird things going on, then you did something, you made a mistake. Okay? Because I'm not trying to do that to you, Dora. So you rest assured it'll be relatively straightforward. It's much more about method than anything else. Okay, so let's say we have this. I'm going to make one like super easy right now. Okay, this is my matrix, let's say, right? And I say, I'll give it to you just like that, I'll say find the inverse by hand. Alright, well what you do is the first step is you augment the matrix with what? An identity matrix of the same order. Right? And then what do I do? I make the left side an identity matrix by doing row operations, and I apply my row operations to the right matrix as well. So this is clearly already 1, 0, 0, so that's good. I want to make this one 0, so I'm going to add the second row to the third row. So this stays the same, the first row for now. 1, 0, 0. Add the second row to the third row, I get 0. 2 minus 2 is 0. 4 minus 3 is 1. 0, 1, 1. Right? Make sense? Okay. Then I want to make this a 1, so I divide that whole row by 2. 0, right? And then I got to get rid of these 2's here. So I'm going to do 2 times this row and then subtract it from this row, right? So 1, 0, 0, 2 times 0, 0, 1, 2 times.
Wait, you said 2 times row 2?
2 times the third row and subtract it from the first, right? So that'll make out -2, 0. That stays the same. This is going to be -2 because it's 2 times 1 is 2, subtract it from 0, and that's -2 as well. And I do the exact same thing with the second row. That becomes 0. That stays 0. 2 times 1 is -2 is 2. -2 plus 1/2 is -3/2. -2 plus 0 is -2. 0, 0, 1, 0, 1, 1. And then if I leave that, you did most of the work, but it's not accurate. You have to then say that, for instance, when my original matrix was A, you have to write, specifically write, A inverse is -2, 1, -2, and just rewrite the matrix from the right side. You have to write that, because that's what shows me that you actually know that that's the inverse. And that's it. Any questions on that? Okay. Can I erase it? Got it? Makes sense?
I was like paying attention to those already.
Okay. Take your time. Get to this step, I did row 3 plus row 2, and then I also did 1/2 of row 2. And to get to this step, I did -2 times row 3 plus row 1, and -2 times row 3 plus row 2.
Very good.
Last thing, can I erase it? Last thing is the determinant of the matrix. If I ask you if I have matrix A equals A, B, C, D, and I ask you for the determinant of A, by the way, this is the notation, DETA, DET of the matrix is the determinant of the matrix. What is that?
I thought it was dot.
What was that?
I thought it was dot.
Oh, he thought it said dot.
Yeah.
Oh.
I wrote down dot.
Oh. Really?
Yeah.
I was like, maybe you're right. It's determinant in the book. Okay. All right. The determinant of matrix A is a 2 by 2. You guys remember what it was? AD minus CD. It's the same thing that we used for the inverse of a 2 by 2 matrix. It was 1 over the determinant of that matrix. Okay, so if I have matrix A equals 2, 3, 7, 9, find the determinant of matrix A. Okay, pretty straightforward. 2 times 9 minus 7 times 3 equals 18 minus 21 equals -3. Yes, ma'am.
I got all the empty part except for the middle one. I got -1, and you got -3 too. I don't know why you got -2.
Because it was -2 plus 1/2. -2 plus 1/2.
That's just -2.
-2 times this row.
It's 1/2.
You did -2 times this row, right?
Yeah.
To get rid of that 2. And then add it. So what's -2 times 1?
22.
What's -2 plus 1?
Wait, but why did you do +1?
Because you're adding this row to
Add
that.
2.
Got it?
Sorry.
Yeah.
For this one here, your first step is row 2 plus 3, right? Not 3 plus 3.
Yeah, it makes the same thing, but just knowing like you're adding this row to that row.
And you change the row you're adding to, right?
What is that?
You change the row that you're adding to.
Exactly.
So then row 2 plus 3.
Yeah. Yeah, whichever way you want to write it, you think about it, it's fine with me.
But I just usually do it like that.
Alright, cool?
Alright, next
Okay. You guys got this? Okay. Alright. Last thing. Determinant of a larger matrix. By the way, class, you can do a determinant of much larger matrices than a 3x3. I don't know if I gave it to you in homework. Too larger, but I'm not gonna, on the test, I'm not gonna do it larger. I didn't explain it. So let's say I have a matrix A equals 1, 0, or 1, 2, 4, 0, 1, 7, negative 2, 3, 1. Let's say. Okay? And I want to find the determinant of matrix A. Okay. Which row should I expand?
Oh, that was a 0.
Row 0. Do the second row first. Learn your lesson. Learn.
I guess.
Do the row with the 0. And we're not always going to have a row with a 0, but if they have a 0, you should do that row. Because then you don't even have to worry about the first term. Remember, class, that my cofactors goes plus, minus, plus, minus, plus, minus, plus. Right? So the determinant of A equals, to do, first I would start with this one, but since it's 0, I don't worry about it. So I go on to my next one. Do cross out this and this, and I'm left with positive 1 times 1 times 1 minus negative 2 times 4. And I go to this one, and I get negative 7 times negative 7 times 1 times 3 minus negative 2 times 2. Ends up as 1 times 1 plus 8 minus 7 times 3 plus 4 equals 9 minus 7 times 7 is 49 equals negative 4. Okay. If I expand with the first row, should I get the same answer or a different answer? Same answer. Let's do it and see what we get. Let's expand the first row. Okay.
So for the test, we have to do one row.
What?
For the test, we have to do one row.
Yeah, you only have to do. Okay. The determinant of A expanding along the first row. First column, first column, I cross out. I get 1 times 1 minus 3 times 7. Go on to my next column. Minus, that's negative, 2 times 0 times 1 minus negative 2 times 7 plus, because this is positive, third column, 4 times 0 times 3 minus negative 2 times 1 is 1 times 1 minus 21 is negative 20 minus 2 times that's 0, positive 14 plus 4 times that's 0, positive 2 equals negative 20 minus 28 plus 8 equals negative 4. Same exact answer as I got before. What about if I expand it along the third row? Would I get the same thing?
Yes.
Okay. Should I do that now or should, yes, Brandon?
Can you explain like the plus minus plus? Like,
Yeah. So, the way that this works is you start at the top left corner with a positive, and then you alternate. Minus, plus, minus, plus, minus, plus. Okay? I alternate, so it's like plus, then minus, then plus. Then the next row starts with a minus. Oh, it should have been a minus sign on the way. Minus, plus, minus, and it starts plus. Got it?
You write your answer. What do you mean?
And so then I apply that to each term. So for instance, this was 1 positive, so it's positive. This is 7 negative, so it's minus 7. Make sense? If that was a negative 7 though, it would be a negative negative 7, so it would be positive. Does that make sense? Yeah? Let's do the third row. Shall we? Okay. Determinant of A equals third row, first column, plus or negative 2, 2 times 7 minus 1 times 4, 2 times 7 minus 1 times 4. Move on to the next column. That's a minus, you see that? Minus 3. So minus 3 times 1 times 7, and that's 0, so it's just 1 times 7. Got it? Okay. Then the last one is positive. Positive 1. 1 times 1 minus 0 times 2, that's just 0. So it equals negative 2 times 7 is 14, minus 4 is 10, minus 3 times 7 plus 1 times 1 is 1 equals negative 20, minus 21 plus 1 equals negative 40. So I got the same exact answer, all 3 times. And that's it. That's your test.
Okay. Can we use some questions?
What? Sure, I'll give you a round.
Extra homework number 3.
Okay. Make me work hard. You got 12 seconds left in class.
Alright, I heard that.
All right. 3, 7, 9, 2, 1, 0, 3, 6, 5. Find the inverse and the determinant of this matrix.
Should I just join homework tomorrow?
What was that?
Should I just join homework tomorrow?
You can turn it in today for extra credit. It's up to you.
Wait, it's still the question 1. What should I do?
Which question?
Number 5 and 17. Number 5, I was going, and
On what page?
5 or 7.
You should just multiply the two matrices. Multiply the two matrices, you get the inverse. I mean, you get the identity matrix. So if you multiply the two, you get the identity matrix. Class, if I ask you to show that two matrices are the inverse of one another, what should you do? Multiply them and show that the answer is the... Very good. 17, they find the inverse of the matrix.
I found the inverse, but I don't know somewhere along the line I have wrong, but I can't get the answer back on the like that. And I read about with accents. That was going over in tracking what I did wrong.
So we can just multiply that and calculate.
If it get
What?
When you ask if one is like the main dominant.
If I ask you, I'll be very specific if you can or cannot use your calculator on the questions.
letters, do not use your calculator in this question.
Yeah. But if I say don't use your calculator, it means show your work. Yeah, it's tough.
I mean, I followed these all night. It was like really here. I got the last one, but I think the second one. I'm taking off my mask. Oh, it's stuck on my glasses. Fantastic.
Since I added 2 plus 3, I had 2 plus 3 on this side also.
And I did that first, so I did that before I divided it. What? That's only when you're finding the term. No, you shouldn't be applying that. We only apply that during the term. But look, negative 17, it's just
You look like you have to tell me something on why us. That's true, man. An interesting logic.
no, that's not fine. We just multiply these matrices. Just by that. It's 2 times 1 minus 17.
Do you still have mine? No, the thing. Here it is. No. You know
This does this. This does this.
but that was you like me. I can't
Oh. Sure, it's still recording.